Everyone, we will solve this today's LeetCode problem. This is remove nodes from linked list. Let's see what it is. So this is a LeetCode medium. So you are given the head of a linked list. Remove every node which has a node with a greater value anywhere to the right side of it. Return the head of the modified linked list. Okay. So we have given that we have given a linked list, and we need to remove every node which has a node with a greater value anywhere to the right side of it. What does it mean? It means, like, if you see this 5 and 2, and after this 13 is greater than 5 and 2, right? So we need to remove this 5 and 2, because in the right side of 5 and 2 there is a greater element which is greater than 5 and 2, right? So we need to remove this 5 and 2, right? So after this 13, this 3 and this 8 is not greater than this 13, so we will not remove this 13. But to the right of this 3 there is an element 8 which is greater than this 3, so we need to remove this 3, right? So ultimately what we need to do, we need to remove the nodes which is in decreasing order, right? If you see here, this is in decreasing order, 13, 8, right? So ultimately we need to remove the elements and make the linked list in a decreasing fashion. So this is the question which we need to solve here. Okay. So if you see, we need to delete the nodes if that is a smaller value, that is a smaller value to the right of any node value, right? So if you think, what we need to do, suppose, don't think it is a linked list, think it is as a array, right? So if we think it is an array, so what is this, 5 to 13, 3, 8, right? So if you solve this by thinking an array, what will you do? You will start iterating, right? Start iterating from starting, and you see that whether any elements is greater than this mine is previous value, right? And if you will get any elements, you will delete all of this previous value, right? So don't you think you need to traverse it from last? Because if you traverse it from starting, you will not able to find at which place this value is greater than the previous value, right? So but if you start from but if you start last last element, you can find the maximum, right? You can find you can you know the maximum value till that place, you know the max value from right beforehand, right? So that will be easy to know that whether this value is greater than this current value or not, right? So suppose I have started from the 8 value, so the max value is what, 8, right? The max value is 8. When I comes to 3, so 3 is less than this 8, so I need to remove this 3, because 8 is in the right of 3, right? So I need to remove this 3, so I will remove it, right? 13 is not greater than 8, 30 is not 30 is greater than 8, so we will not remove it. But the maximum value now becomes 13, right? The maximum value now becomes 13. So when we go to 2 and 5, this both is less than 13, so we will remove this. So what will ultimately be left? This 13 and 8, and that is the answer we got here, right? But this is using this, we think this as a we thought this as an array, right? But how do we think in linked list, right? So we have started from the last element, but in linked list, we are not able to move in previous, we can only move in forward, right? In the problem here is the problem here is we can only move forward in linked list, right? Linked list, right? So how we will move in, how we will move in the backward direction, how we will move in backward direction, move in backward directions. So if you think of any approach, You can think of backward. How will you backward do this? So what we need to do, can you think of any data structure used for backward directions, right? So if you think of stack, what it is a last in first out, right? This is last in first out. The last element which is inserted in it can be taken as a first object, right? So if I insert 5 to 13 3, 5 to 13 3 in my stack, so popping out popping out, it will be in reverse direction, like 3 13 2 5, right? It is in reverse direction, right? Reverse direction. So can we use a stack here? So let's see, right? So if I start from 5 and 2, it is just as a simple stack based problem. So if you have solved any previous stack problems, you were like valid parentheses and all, you what will you do? You insert the nodes in that, and we will check that whether this current element is greater than the previous elements which is inserted in my stack. If it is, then we will pop that out, right? So that I will use that simple approach in here also, right? So if I started from stack, so the first is 5, right? So we will insert this 5. Second is 2, we will insert this 2. Now the third is 13, right? So before inserting this 13, I will check that this whether this current element is greater than this its previous top elements or not. So though although I have my 2 13 and 8, I have my 5 and 2 in my stack, and this 13 is greater than this 2 and 5. So we will remove this 2. Again, this 5 is less than 13, we will remove this 5 also. Now the stack is empty, we will insert this 13 here, right? Now again this 3, when this 3 is greater than 13 or not? No, it is not greater. Then we will not pop this out 13 from stack. We will insert this 3 in it, right? When we go to 8, this 3 is less than this 8, so we will remove this, right? And now this 8 will be inserted because 13 is greater than 8, right? So ultimately this 13 8 will be the answer, right? So this is seems to be easy by seeing like this, but implementation using linked list is some bit difficult. By you need to implement it very carefully, right? So for that, what we can do is, for that we can use a dummy node, right? We can use a dummy node which is a which can be the maximum element. Why? This is 10 for 5, so can we take it as a 1 is 6, right? Now this approach is for using stack, right? This is using stack. So we will insert this dummy node to the greater element, because we need to remove the elements which is at we need to find the maximum element which is at right. So we will take as a 1 is 6, which is the maximum element in whole of the linked list, right? So what we do, we will push it in my stack, right? Now we will check for every element which is greater than this dummy or not. So it is not greater than, we will insert it. So this is the same process we do in the stack, right? But for the implementation, when we are removing this stack, uh, suppose here we have inserted 5 then 2, now this 13 comes. Now this 5 and 2 is connected, and 2 is connected to 13, right? This is something like this, 13. Now when we need to remove this 2 and 5 from this stack, and also need to delete it from the linked list. So uh, for deletion, what we do, we point this next can we point this next to null, right? We can point this next to null. So it is something like this. The previous was dummy, then 5, then 2, then 13, then 3, then 8. The previous was like this. Now this 13 is greater than 2, so this 2 need to be deleted from here. So can we mark this 2 connects to null? Yes, Yes, we can mark. Yes, we can definitely mark this. We can definitely do this, right? If we do this 2 connects to null, this 2 will be removed from this dummy part. How? And what we'll do, this 2 will be removed. Similarly, this 5 we also remove. So this 5 to next value also null. So 2 can next is null. Again 5 can next is null. But this dummy value is greater than 13. So at last what we'll do, we will pass this dummy connects pass this dummy connects to the current null, which current node, which is 13, right? We will made this 13. Now ultimately what is made, this dummy to 13, and now this 3, this 8, right? This will be formed, right? Ultimately, now again after going towards 13, this node as the 5 and 2 pop out, and this 13 will be left here, right? Now when we move to 3, this 3 is greater than 13. No, it is not. So we will insert this 3. Now we will check for 8 whether this 8 is greater than this 3. Yes, it is greater than. So again we will do the same thing. We will assign this 3 connects to null, to null, and also we will pop this out. Now this 8 is less than this 13, so we will don't do anything in this, and we will simply mark this 13 connects to this 8 value, right? And we will push this 8, and ultimately what will return as an answer? So answer will be this dummy ka next answer, right? This should be the answer. So what we are, if we generalize this, if we generalize this, what we are doing, we are inserting, we are checking every element while with before pushing. So if we generalize this, we are inserting an node in our stack, we are in our stack, but before we will check that the node value which is in my stack should be check that whether this node value which is in my stack is greater than or not from my current element, right? Current node value, right? This we are checking, right? And if the node is, if the node, if the stack node is less than, then we will pop out and also remove that. We will pop out and also, then we will pop out and also remove from linked list, right? Linked list, right? So what we are doing, and at last what we are doing, we will connect that node to current node. So and at last we are connecting the node to current node, the stack node, which is not removable, which will not, which we will not remove, to current node, right? So this should be the approach here, right? This will be the approach. I hope you understand, because it's a basic valid parenthesis type question in stack, right? So let's see how we will implement this, right? So firstly, what we need to do, we need to make a stack value, which will be a list node type, right? And also I need to make a dummy node for storing the dummy value, which will be the greater than the maximum value, which is 1 is 6. So 336, 336, right? And now what we'll do, we will point this dummy to next value, to head, and we will also make a temp value which is pointing to this dummy. Now we will iterate in this temp. So now we will insert this temp value in my stack. But before pushing this temp value in my stack, we need to check that this st.top का जो value, the uh, the st.top value should be, if it is greater than the temp value, we will remove this, right? We will remove this. Why? Because this is temp value is in right of this st.top. So if it is greater than, it means I need to remove this node, right? So for removing this, what we can do, we can simply point this next to null and pop this out from a stack, right? So after this, so after this, I will also insert this temp in my in my stack. But I also need to connect which is still left in my stack to this temp, so that the linked list is connected. How? This, like this 13 and 8, right? So for that, I need to take a bool variable, so that I know that I have I have removed some of the nodes from my stack. So if this f is true, it means I have removed some of the nodes from my stack, and I will point this top value connects to this temp value, right? And I will again iterate this in temp connects, move to the next value. So what does this do? This st.top will do that, it will connect to this temp value which is left, right? So why have I not checked that this st is empty or not? So because just give me a second. This should be temp also, right? Because it is at a starting point. I have not inserted anything in my stack, right? So I need to check this. So why I'm not checking this? Because this dummy node is very greater than the total number of nodes, which is 1e5 here, right? So this will be never be neglected. This will never be removed from the stack. So before accessing st.top, I am assured that there must be an element present in st.top, because this is very greater than, and this never be removed from, right? So I will point this to temp and push this also, and I will again move to the next step, which is temp connects, right? So this is how we will remove the nodes and connect all the nodes. So at last, what we will return? We will return this dummy connects, because the dummy next will point to this head, right? So we will return dummy ka next, right? So let's run this. So yeah, we have passed the sample case. Let's submit it. We have successfully passed this submitted. So let's analyze the time and space complexity, right? So time complexity will be O of, what will be the time complexity? We are iterating temp in whole direction, like from first to start, and also I need to iterate in reverse direction. But that is, if you see here, this while and temp, this is only one time process, right? If we are reversing it, so we will reverse it till this is not for every node, this is for only when it is greater than value. So yeah, right. So due to this O of n, and this is due to this O of n, so that will be O of 2n, not O of n square. Don't see this while and while, see this like we are iterating only, we are going in a reverse direction only one time, and we are going in forward direction only one time. So that will be O of n plus O of n, right? O of n plus O of n, that is 2 O of n. Ultimately it is equals to O of n, right? That is equals to O of n. And the space complexity, what will it be? So we are using a stack here, right? So it can be possible that all are the at the right position is less than the left position, right? So that will take O of n, right? So the worst, and the at worst case, the time and space complexity will be O of n and O of n, right? So this is how we will use the stack for for this question, right? But can we more further optimize it, right? So if you see, this time complexity will can never be optimized, right? Because in linear in constant time we can't find that which nodes need to remove. So can we further reduce this space complexity here? So let's see, can we reduce this space complexity? So what we are doing, we are removing we need to iterate in reverse order, right? We need to iterate in reverse order. That's why we are using a stack. So instead of using a stack, can we simply can we simply reverse this reverse this linked list, right? So what will be benefited by if we reverse this linked list? So you have solved this reverse linked list problem, right? That will be the same approach. So after reversing it, what will it become? It will become 8, 3, 13, 2, and 5, right? Now the problem was before the what we are facing the problem before. So the problem which we were facing before, that we can't move in backward direction in linked list, right? Now, but after reversing this, we can move in backward directions, because this is make I have made this in forward direction. So we can move in 8, 13, 13 to 5, right? So can we now, no, now this, don't you think this will be an easy to remove whenever the element is less than the previous element, right? So what will we do? We will store the maximum value, max value, during during iteration, right? So we will store the maximum value during iteration. So suppose this max value is 8 here at the starting point. Now 3 is less than 8. So this 3 should be need to remove, right? So for this 3 need to be removed. So what we will need to do? We will need to point this 3 connects to null, right? And so what we need to do? We need to make this 8 point to 13. So for this 3 connects should be point to this 8 connects. So for this 8 next should be equals to 3 next, right? This 8 next should not point to this 3, although this should point to 13, which is 3 to next. So this is 8 to next is equals to 3 to next, and the 3 to next should point to null. So this is how we will remove this 33. So this will become now 8, 13, 2, and 5, right? Now when we when now this temp previously this temp was on 3. Now this temp next to next is 13. So this is becomes 13. Max value is also becomes 13, right? So this 13 is equals to 13. So we will don't do this anything. Now this 2 value, when temp becomes 2, so this 2 is less than this 13, which is at max. So this 2 should be removed. So for that, this 13 should point to 5, right? And this 2 should point to null. So this 13 next value should be equals to 2 next value, and this 2 next value should to point to null, right? So after this, what will be this linked list will become? This will become this, right? Now this temp at 5 and max is again 13, which is greater than this 5. So we need to also remove this 5. So what we need to do? We need to do this again. This the same thing, just 13 next to 5 next and 5 next to null, which is now temp will become next to next, which is null, right? So ultimately this linked list will form, but this is the reverse linked list. But this linked list is in reverse form. So we need to again reverse this to get our final answer, right? So after reversing this will become 13 and 8, which is again our answer, right? So what we are doing here, what we are doing here ultimately, first we are reversing the linked list. We are reversing the linked list, right? So that we can move in forward direction, right? Now we will we are storing max value and checking all the values which is greater than or less than the max value, right? And if it is, and if the current value, if the current node value is less than the max value, we will delete it from node. We will delete it from node, right? From linked list, sorry, from linked list, right? And at last we need to again reverse it reverse it to get our answer head, right? So this should be the approach using reverse node, right? So this is how we can use a reverse linked list concept, which is a basic concept. So okay, this should be removed from here. Let's remove this code from here. Remove it. Okay. So okay, so how we will reverse this linked list, right? So let's understand this also. Suppose here it is given 5, 2 and 13. So for reversing this, what we need to do, we need to take three pointers approach. The first will point to null, the second is current which is at equals to 5, and the third is next value which is at 2, right? So this is the three pointer approach. Now what we need to do, we need to point this 5 to previous. So what we need to do, we need to point this 5 to previous value and 2 to 5 value. So ultimately what we need to do, this 5 should be like this, right? This should be like this. So 5 to next value should be point to previous. So this current next value should point to previous, right? And this previous, and also need to shift it from this. So this 2th value, the current value is 5. Now we will, what we do, we need to make this previous as current, so that this previous now comes at 5, and this current should be at next value, right? So what it becomes now, it will becomes like this. So this previous will becomes now 5, current will becomes now 2, and the next will becomes like 13, right? So this is how this will be. Now this again current next points to its previous. So this current is at 2, so current next will point to this 5. So and this previous is again here, so this will remove from here, right? And this 2 points to this 5, again this 13 will points to this. So this will become again this, and this will become again this. So this is how we will reverse this again. This is how we will reverse this. So current next to previous, previous next to current, current is equals to next, and this is how we will shift this all the pointer approach. Uh, if you want to see this, I think I have a video on this. If you want to learn this, I have a video in my channel. uh, I think I have a video. I am not confirmed. I think I have a video, right? I have a video in my channel, right? So let's watch this. But this is the core concept of reverse linked list, right? So let's run this, right? So what we need to do, we need to make a reverse linked list function, right? So this is how we will make. So let's pass this as a current or head. Oh, this should be head. We need to take three pointers for that. So this is previous which point to null, again this current which will point to head, right? Now we will move in this current function, and now we will also need a next value which will point this current to next, right? So here is the three pointers. Now we will use this three pointer to reverse it and shift these three pointers again to the next of values to for reverse. So what will we do? We will point this current next to previous. This previous should now comes to at current, and this current should comes to at next, right? This is used for reversing. Now this previous and current should shift to next pointer to reverse it, and ultimately I need to return this previous, because this previous will be add head of this reversing list, right? So now for this head, what I need to do, I will just need to reverse it, right, first. And after reversing, I need to delete it. I need to store this max value, and also I need to iterate in this temp value which is pointing to head. Now what we are need to do, we need to do this. We need to check every node value which sorry, this should not here, right? We need to store a max value and check all the values which is greater than or less than the max value, right? So we will do this like, so we will store the max value which is the temp value, right? So we will check that whether this temp value is greater less than the max value. If it is less than the max value, it means it should be removed. So for removing this, I need to for removing this, I need to point the previous value to isca next. So also I need to maintain a previous value. So for that, let's previous value as null to maintain this. Now what we'll do, we will point this next value, previous next value, to temp next, and this temp next should be null. This is how we delete a node from linked list, right? So what we have done, this temp should be removed. This temp should be removed. But this temp must be removed. Must be removed from linked list. So for that, I need to mark previous, its temp previous next to temp next, and temp next to null, so that this temp value will remove from linked list, right? So this is how we will remove it. And if this temp value is greater than mx, so what we need to do, I need to mark this previous to temp. So what why we are marking this previous to temp? Because after iterating this temp, this will be previous can next, right? So ultimately what I'm trying to do is here, I am shifting this temp to the next value, and the previous temp value should mark at present previous. Then we are, I am just updating the shifting these two pointers again and again, so that when I need to remove this temp value, I will just mark this next to next, right? So I am just shifting two pointers again and again on this linked list, right? So this is how we will remove all the nodes which is less than the maximum value. And at last what I need to do, I need to reverse it again, because I this is the reverse linked list and we have found the answer. So for the final answer, I need to again reverse call this reverse function, and I need to again call this head function for reversing it, so that I can get the final answer. So let's run this. Okay, previous next should be, so what is wrong here? List node is a pointer. Did you mean to use dot? Okay, sorry. This should be at a start, because this is a pointer, right? So let's run this. Yeah, we have passed this. Let's submit it. Yeah, we have successfully passed this test case. So what we are doing, we are first reversing it, then we are removing it, removing the nodes, and we again reverse this, right? We are again reversing this. So what will the time and the space complexity? So the time complexity will be O of n plus y of n for reversing this head, right? Again we are iterating this temp in whole for removing the node, for again O of n for removing the nodes. Now again we need to reverse the whole linked list, so that is again O of n, right? That will become O of 3 into n, which is ultimately O of n, right? We can write it as O of n. And the space complexity, so we are not using any other data structure or extra spaces here. We are using just a linked list which is given, so that is O of 1, right? So we have successfully reduced this time complexity using reverse linked list, right? Hope you have understood, right? And this reverse linked list concept you can watch it again, right? So this is how we will solve this problem. So thank you, have a nice day, bye bye.